In this example, we're going to multiply a scalar, which is a number, times a matrix. And we do that by distributing multiplication to every entry inside of the matrix, distributed across every entry. So if we have -2 for the scalar, that's just a number, multiplying the matrix, -1 down below 3, 4 down below 1, distribute -2 multiplication to the top, -1, and to the bottom, -2 times 3, then the upper right, -2 times 4, and the lower right, -2 times 1. Now simplify by doing the multiplication. We get 2 down below -6, -8 down below -2. And you'll notice it doesn't change the order of the answer. The answer is still going to be a 2 by 2 because all we did was multiply each of the entries in the 2 by 2 by a number. Let's try to do this thing backwards. Let's factor out a scalar. Factor a scalar from this matrix. So in this matrix, we have some pretty big numbers. We have 24 down below -6, 18 down below -12. Now, the greatest common factor for all of these four numbers would be 6. So we're going to factor out the greatest common factor from all four entries and bring it out in front of the matrix. So first, we'll factor each of the numbers individually. So 24 is 6 times 4. And down below, -6 is 6 times -1. And then up above, 18 is 6 times 3, and -12 is 6 times -2. And the last step, we pull out the 6. It leaves 4 down below -1 and 3 down below -2. So we did multiplication in part A, and then we did the backwards operation, the opposite, inverse operation of multiplication. We factored out the scalar in part B.